Hi everyone, today we're going to study simplification using quotient property. First, let us define this quotient property of radicals. Suppose there are two radicals, the nth root of A and the nth root of B. Take note that the index are the same, and these two radicals are real numbers. Another condition is the B, which is the radicand of the second radical here, should not be equal to 0, or else this radical will be equal to 0. So that's why it is given the B should not be equal to 0. And for any integer n, and that n is the index, should be greater or equal to 2. Then we are going to divide the nth root of A by the nth root of B. The answer is a big radical with the index n. Inside the radical is a fraction, whereas the numerator is A and the denominator is B. So this equation here is what we call the quotient property of radicals. Suppose I have a big radical here with an index n, and inside the radical is a fraction A over B. To simplify this using the quotient property, we're going to distribute the radical to the A and to the B respectively. As you see, this is now equal to the nth root of A over the nth root of B. This is actually now called the simplification rule based on that quotient property of radicals. If you notice, this equation here is also that quotient property, but the position of the left side and the right side members are interchanged. Now let us simplify a radical expression using the quotient property. We're going to follow some steps. In step 1, we're going to simplify the fraction in the radicand, if possible. Step 2, use the quotient property to rewrite the radical as the quotient of two radicals. Step 3, simplify the radicals in the numerator and the denominator. Let's have some examples. Let us consider this example 1. Simplify the cube root of the fraction 32 over 54. In step 1, we need to simplify the fraction in the radicand, or simply we need to reduce the fraction to lowest term. You see the 32 is factored out into 2 times 16, and the 54 is factored out into 2 times 27, and then the number 2 in the numerator and in the denominator is there. It's common that we can cancel. So now the radical is simplified into cube root of 16 over 27. We will now go to the step 2 where we're going to use the quotient property. It means we're going to distribute this radical sign to the numerator and in the denominator. So we have the cube root of 16 and then the cube root of 27 in the denominator. We're going to check the radicand of each of the numerator and denominator if they are in the form of a perfect n number. Since our index is 3, we will check if the numbers are a perfect cube number. In the numerator, 16 is not a perfect cube number. In the denominator, 27 is a perfect cube number. So what we'll do now, in the numerator, we're going to think of factors of the 16 such that one of the factors is a perfect cube number. In the denominator, we're going to show this 27 to be 3 cubed. And then, in the numerator, this number 8, we can show it to be 2 cubed. And then the other factor, 2, will be copied down here. In the denominator, we simply copy again that same value. Now, in the numerator, we're going to apply simplification using product property. It means we're going to split the radical into each of the factors. You see here we have the cube root of 2 cubed times the cube root of 2. Then in the denominator, we can now simplify by cancelling the radical and also that power 3. So only the base 3 will come down here. In simplifying this first term here, we are now to cancel the radical and also the power of 3. Only the base 2 will come down, and then multiplied by this cube root of 2 all over the denominator 3. So this is our final answer. Let's have example 2. Let us simplify the fourth root of the fraction a raised to 10 over a squared. In step 1, we need to simplify the fraction in the radicand. So we have here exponent with the same base. We can apply our rule that it is equal to the a raised to the 10 minus 2. And then the big square root is outside with the index 4. So it is now simplified into the fourth root of a raised to 8. Step 2 can now be omitted because there is no more fraction inside our radical. So in step 3, our index here is 4. So we're going to show that this a raised to 8 is a power of 4. The term inside here is a squared. So now we can cancel the radical with that index 4 along with that power 4. And the answer is this a squared with the absolute value symbol. That exponent 2 will make the value always positive, so we can simply delete that absolute value symbol. So the final answer is a squared. Let's have example 3. Let us simplify this big radical, and inside is a fraction. The numerator is 18, p raised to 5, q raised to 7, all over 32p q squared. In step 1, we need to simplify the fraction. In here, we're going to group the numbers. We're going to group the variable p. We're going to group the variable q. So for the numbers, we're going to reduce to lowest term. So the 18 is now factored out into 2 times 9. The 32 is factored out into 2 times 16. As we can see, the factor 2 is common. Later on, we can cancel that. For the p, there is an exponent of 5 in the numerator. There is p in the denominator with exponent 1. So we can show that this is p raised to the difference of 5 minus 1. And for the q, we have in here q raised to 7 in the numerator. We have q squared in the denominator. So we can combine them by putting q raised to the difference of 7 minus 2. For the numbers, we can now cancel the 2 and 2. Only the 9 over 16 will come here. For the p, 5 minus 1 will be 4, so p power 4. For the q, the 7 minus 2 power will be 5, so q raised to 5. And from here, we're going to combine the 9, the p raised to 4, and the q raised to 5 in the numerator. So on this line, we have the square root of this fraction. Numerator is 9p raised to 4, q raised to 5, all over 16. We are now in step 2, where we're going to apply the quotient property. It means we're going to distribute this radical sign to the numerator and to the denominator. The next is, in the numerator, we're going to distribute the radical to each of the factors here. So you see we have the square root of 9 times the square root of p raised to 4 times the square root of q raised to 5 all over 4. So this is now the square root of 16 is now simplified into the number 4. The next is, we're going to simplify further the numerator. The square root of 9 can now be simplified into number 3. This value p raised to 4 can be represented by p squared and again squared. This q raised to 5 now can be factored out into q raised to 4 times q. So we put here q raised to 4 because our index is 2. We're going to put one factor with the exponent that is the highest multiple for the index. So this is q raised to 4 times q. The next is that q raised to 4 we're going to represent by q squared and then squared. And then this times q, just copy. Next, we're going to split now the radical to the factors. Actually, that is simplification by product property. We have now here the square root of this q squared and then squared times the square root of q. The next is we're going to cancel now some terms that can be cancelled. So in this answer, the 3 we copied here. For the second term, we cancel the radical with the power 2. And then only the p squared will come here in the final answer. We cancel the radical, also that power 2. Only the q squared will come here. Next is this square root of q we include in the numerator. And then all over 4. So this is our final answer. Thank you for watching. See you again next time.